Presentation on object-oriented programming in Python. We have come across the 4 pillars of object-oriented concept in our OOP class, that is the abstraction, inheritance, polymorphism, and encapsulation. Let us go a step further and understand how these OOP concepts are implemented in multi-paradigm programming language Python. The following are the contents that will be covered in today's presentation. We know that a class defines a data type which contains attribute and methods, and an object denotes an instance of a class. In Python, a class is created using the class keyword, and the fields and methods of the class are listed in an indented block. Consider a simple Python program wherein a class person is instantiated. When you execute this Python program, it gives the address of the main memory where the instance is stored. It means that the instance of the person class is created in the main module. Class methods in Python have one difference from ordinary function, that is, they have an additional parameter that is added to the beginning of the parameter list. And when you actually invoke this function, you don't pass any value. And this special parameter is nothing but it's the self, and it is a reference to the object itself. In Python, class methods that begin with double underscore have got special meaning, and two such functions are init and the delete function. Init is like the constructor of the class. It gets called whenever a new object of that class is instantiated, and you don't explicitly invoke the init method. And the delete destructor is invoked automatically when an object of that class is about to be destroyed. Now let us go ahead and run a simple program that consists of class media, and two instances of class media, that is the book and DVD, have been created. One particular thing to notice here is the way the class attributes are accessed. That is, type is an attribute of a class, and the way it is accessed is in this manner. Now let us go ahead and run the program, and we see that the type attribute of the class is of media for the book, and it is the same for DVD as well. At property is an interesting concept in Python. It is used to perform the operation of converting class methods to read-only attributes, as well as implementing getters and setters into an attribute. It is a decorator. The advantages of using property is validation. That is, before setting the internal property, we can validate if the provided value meets some certain condition and throw an error if it doesn't. It is also used for lazy loading. That is, resources can be lazily loaded to defer the work until actually needed. And abstraction is one more advantage, that is, the getters and setters allow us to abstract the representation of the data. In this program, we are using property decorator for creating getters and setters for class instance variable title. So we have a title function here. This is nothing but a getter function, while this is a setter function. One interesting thing to note here is the way the getter and setter function are accessed. It is similar to accessing the class attributes, that is instance dot the getter and setter attributes. Let us go ahead and run the program, and we see that it prints out the title of the. Here title behaves as a setter function for media class object, and here title behaves as a getter function for media class object. Static means a member is on a class level rather than on an instance level. Static variables exist only in single instance per class and are not instantiated. All the variables defined on class level in Python are considered static. Now let us go ahead and check out this program. Here the number of books is a static variable, and we see that it is accessed using the class name. The title and the author are the class instance variables. We also see that the number of books class variable is accessed using the class instance variables. This means in Python the classes store two copies of the variable, that is, one is static and the other one will be treated as an instance variable. If we go ahead and run this program, we see that the instance the b1 instance of book class has a value of 1, whereas the static value is also 1. But when you go further and modify the variable and set b2 instance, for the b2 instance you set the number of books as 4, and you try to increment the static variable only by 1, and you see that the output is 4 and 2. Python has two kinds of static methods, and it uses the decorator at static method and at class method. Now the static method shares with the class only the namespace, and it can access the static variables. It is bound to the class but not to an instance of the class, and it cannot access or modify the class state. But the at class method, it can access and modify the class state because it takes a class parameter that points to the class. Now let us go ahead and run a code snippet on class methods and the static methods. Now here, from media type is a class method, whereas isBook is a static method. isBook checks if the type is book and returns whether it's a book object or a DVD object, and from media class it returns the class that contains the title and the author type. And here we access the class method by using the class name. Now let's go ahead and run this program. Yes. Now we see that when you pass isBook the static method for media1 type, it says the book object is created. Inheritance is the process of defining a new class from an existing class. Rather than replacing the functionality of an existing class, you extend it. Derived class inherits features from the base class and adds new features to it, and it results in the reusability of the code. The syntax for inheritance in Python is given in the block below. And in Python, to invoke a base class method, you use the super method. There are two built-in functions to check inheritance here, that is isInstances and isSubclass. IsSubclass is used to check for class inheritance, and isInstance returns true if the object is an instance of the class or any other class that is derived from it. Consider class media as the parent class and class book as the child class. I have an init constructor in both the classes and a get class name which I have overridden in the child class. In the init constructor of the book class, we see that you invoke the base class constructor using the super keyword, and get class name is overridden here in the book class. Now in the driver program, I'm creating an instance of the book class, that is the test book, and when I invoke the get class name, it is overridden and the derived class method is invoked. And regarding isInstance and isSubclass, if I now the isInstance, this method here checks whether if testbook is an instance of the book class. Here it checks if the testbook is an instance of the media class. And in isSubclass method, here it checks if book is a subclass of media, which returns true, and the next line checks if media is a subclass of book, and it should return false. Let us go ahead and run this program. As I said, you see that first initially the base class constructor is invoked, followed by the derived class constructor, and the get class name of the derived class is called. And as I mentioned, is textbook an instance of book class and media class returns true, and if book is a subclass of media class returns true, and if media is a subclass of book class or not returns false. Unlike Java, Python supports multiple inheritance where a class derives from more than one base class. The syntax for deriving multiple inheritance is given in the block in the slide. Python supports multi-level inheritance as well. That is, a class derives from a derived class itself. Features of both base class and the derived class are inherited into the newly derived class. The syntax is given on the right side block. When multiple inheritance is supported, there should be an order in which base classes are searched when looking up for a method. This order is called method resolution order. Python follows simple algorithm when looking up for such method. Here, the base classes are searched using a simple depth first search in left to right fashion, and the first matching object found during this research is returned. In Python, the MRO of a class can be viewed using MRO attribute or the MRO method. Consider a complex multiple-level inheritance hierarchy given in the diagram. Let us go and code this inheritance and run and see what the output looks like. Here we have three base classes x, y, z and two derived classes a, b which inherit from x, y and z, and then there is one more class in multiple inheritance m which derives from classes b, a and z. Let us look at the order when you try to run the MRO method for the class m. Now, when looking up for a method, the first class that is to be searched is the M class. It is a specialized class because it has derived from multiple classes, so it has higher precedence. It is then followed by class B, and then it is then followed by class A. After class B, it doesn't go up to classes Y and Z because we see that classes A also inherits from class Y. So A is more specialized than class Y, so it has higher precedence. So after class A is searched, it then follows up to classes X, Y, and then finally the Z class. Also, if any inheritance hierarchy is inconsistent, Python doesn't support it and it will throw an exception. From here, Ganesh will take over to further present object-oriented programming concepts in Python.
Hi, I am Ganesh and I will be continuing with the explanation of the other object oriented principles. We'll talk about encapsulation now. Encapsulation is the grouping of related behaviors into one accessible unit. In an object oriented Python program, you can restrict access to methods and variables. This can prevent the data from being modified by accident. This is known as encapsulation. As you can see here, the restriction types available in Python are similar to that of Java. There is public variables, protected variables, and private variables. But the way these variables are declared are quite different. Here you can see a public variable is declared with just the variable name. The protected variable is declared with one underscore before the variable name, and the private variable is declared with two underscores before the variable name. We will look into a program to see how encapsulation works. Here you can see an encapsulation class with three kinds of variables: public, protected, and private. We have an object created here called x. Let us try to access the public and protected variable from outside of the class. As you can see here, the public and protected variables are printed, which basically means that public and protected variables can be accessed outside the class. Let's try to do the same with private. As you can see here, an error is thrown which states that the encapsulation object has no attribute named underscore underscore private, which basically shows that you cannot access a private variable. Actually, you can access a private variable, and this is because Python uses a mechanism called name mangling. Any identifier of this type is textually replaced with underscore class name underscore underscore the variable name. So if you use this notation, we can actually access the private variables. As you can see, the private variable is printed here. What this basically means is in Python, it is actually the responsibility of the developer to understand that this variable should not be accessed by seeing the notation. So Python relies on the developers to understand that there are few types of variables that you shouldn't use and a few kinds of variables that you actually can access. So this was about encapsulation. Now let us move into another object-oriented principle called polymorphism. So polymorphism is a method of using different objects in different situations at runtime. Let's see what this actually means by looking into code. Here, as you can see, there is a media class which does not have any implementation of the methods type and shape. And here we have classes book and DVD that have inherited from media, and they are overriding these two methods with their own implementation. So here you can see a driver which has two functions that take in an object we can call media. Though we are using the name media, any instantiated object can be called into this function. Each of the methods in driver class call the type and shape methods, each of which are defined by book and the DVD classes. Next, we have created instantiations of both book and DVD classes. With those, we can call their respective actions using the same methods of the driver class. When we run the program, the output is as follows. Even though we passed in a random variable media to the methods of the driver class, we were still able to see that the book object called the type and shape that were defined in the book class, and the DVD object called the book, the type and the shape function that were defined in the DVD class. So this was about polymorphism. Next, we will look into abstraction. Abstraction. Abstracting something means to give names to things so that this name captures the core of what a function or the whole program does. Let us see a real world example. Think if we are asked to draw a square. What that internally means is we are being asked to draw a rectangle with equal sides. So here, drawing a square is an abstraction to this entire sentence. Now we'll see how abstraction is implemented in Python. What we can see here is this is an abstract class. Actually, Python on its own doesn't provide abstract classes. Yet, Python comes with a module which provides the infrastructure for defining abstract base classes. The module is called ABC. As you can see here, the method make noise and eat are abstract methods and they have to be declared above with these attributes. The function sleep has an implementation for itself. The methods, the classes lion and cat inherit the animal class, and they have actually overridden these abstract methods with the implementations of their own. For an instance of a class to be created, it has to override all the abstract methods of the inherited parent class. As you can see here, we have instantiated an object of lion and cat. Let us see what the output here is. As you can see here, when we call in the object lion.sleep or cat.sleep, we get the same functionality. This is because this method is implemented in the animal class. But for lion, we can see that the method make noise returns roar, and for cat it returns meow. As well as for the animal, as well as for the eat function, the lion's object returns deer, and for a cat object it returns mouse. So this is how you implement abstract methods, and this is how you implement abstraction in Python. So now we'll be talking about composition. Composition means that an object knows about another object and explicitly delegates some tasks to it. We use composition when we want to use some aspect of another class without promising all of the features of that other class. Now let us see a code example to explain composition. Here we have two classes. The first class is class job, which has getters and setters for the variables role, salary and ID. And we can see that we have a person class. This person class has a variable of its own, name, which is necessary to identify the person. The rest of the details that needs to be stored about this person is delegated to the job class by the creation of an object an object of the job class. So let us try to run this program. As we can see, we have created an object of the person class passing all the necessary parameters for a person. And what we could see here is the person class defines name that it was basically created for, and on need delegated the required operations of setting the job details to the job class. This was an example, a perfect example of the composition. In conclusion, what I would like to say is, as an object-oriented programming language, Python does not force certain rules that are necessary for object-oriented programming. Python is a very practical and pragmatic language. It is designed to be hybrid. It can support object-oriented as well as procedural paradigms. Thank you.